Let's take a look at one more argument form and use some of the techniques that we've developed over the previous videos to show that this argument form is valid. First, let's use our intuition. This says P implies Q, not P implies Q, therefore Q. So this could say something like, if I watch the movie, I will be happy. If I don't watch the movie, I will be happy. Therefore, I'll be happy. Intuitively, this is like saying, either way, I'll be happy, so I'll be happy. It makes sense intuitively that this should be a valid argument form. And of course, I could use a truth table to show that this argument form is valid, but I'd like to use our other techniques for showing that this argument form is valid. Intuitively, this is like an either-or argument. I'm saying either I watch the movie or I don't, but either way I'll be happy. So let's split this into an either-or situation as we did with the dilemma. Either I watch the movie, in which case, because of this premise, P implies Q, I can conclude Q, and that's modus ponens. Otherwise, suppose I don't watch the movie, then because I've got this premise here, not P implies Q, then again I can conclude Q by modus ponens. This one is a little less obviously modus ponens. I've used a substitution here which says not P instead of P, but nonetheless this is an application of modus ponens just by making this substitution consistently. Something implies Q, therefore Q. Doesn't matter what that something is as long as it's the same thing in both premises. Now this isn't quite a dilemma because I haven't split it into two branches based on an or in one of the premises here. If I had this premise P or not P, then I could split this into two branches that way. So let's write this down as a premise, P or not P, and then turn this into the dilemma, which says, in this case, I have this hypothetical assumption, and in the other case, I have the other hypothetical assumption. The thing is, I don't have this as a premise. I don't have P or not P. So we need a reason to conclude this. I need to show that P or not P is true. I need to convince you that this is true, or convince you that you should believe it. Well, actually, convincing you to believe P or not P is pretty easy, because this is a tautology. And if something is a tautology, that means it's always true, whatever the variables are. So if this is always true, then you should believe that it's true. So now we're almost done. I've concluded Q in this hypothetical branch, and I've concluded Q in this hypothetical branch, and I've convinced you that at least one of these branches must be true. So at least one of these conclusions must be true. There's one final step, which is to bring them together. In my dilemma video, I showed that we can bring these two conclusions together and say that one or the other is true. So let's do that. Either this conclusion is true, or this conclusion is true. Now what does that give me? It doesn't quite give me Q, doesn't quite give me what I want. It says Q is true or Q is true. So now I need to convince you that Q is true. Well, if you believe that Q or Q is true, then you should believe that Q is true, because those are equivalent. This has the same truth value as this. Therefore, if you believe this, you should believe this. And that's the end of this proof. That shows that this argument form is valid. So the techniques we used here are to say, this is a tautology, so you should believe it. Use the dilemma to split into two branches, and then once I joined them together I used an equivalence to say if you believe this then you should believe this as well because they're equivalent. This is actually quite a common use of the dilemma, to take the or as a tautology like P or not P. I don't need an or in my premises if I can just introduce this tautology and then split into two cases, one where P is true and the other where P is false. And then it's also quite common in the dilemma to join together two of the same conclusion and therefore reach that conclusion as the final result of my argument form. So this is actually a very common application of the dilemma, and this is often what using the dilemma will actually look like.